Now, sound waves, we already talk about it. It's a longitudinal wave and everything in this. So now let's start with the thing. It's a longitudinal wave, everything we know that. There was a small topic related to that, which is called as effect of sound wave. We already done this pitch. So today, what we will do, we will see what exactly is sound. Okay. We know I already told you that pitch means frequency and loudness means amplitude. Okay. We already discussed that. You already written that. Now, the last thing of this topic is called echo. Can anybody give me any idea what is meant by echo?
Sound response back.
Actually, sound response back is called reflection, what you just said. The thing is actually, it means continuously a sound is reflecting back. Not once, not twice, not thrice. It just keep on reflecting, and reflecting. That's what it means. Okay. So when you say reflecting, so reflecting. Okay. So when you say reflecting, it's reflecting. Okay. So when you talk about reflecting, just write it down first and then we will talk about that quickly, please. Has everyone written it? Please let me know.
I'm done.
You have done this. Let's see whoever just wrote it. Let me. Okay. Now let's quickly see what exactly they are all, because you're continuously writing it, and let's see. The things are very simple. When sound wave reflect of hard surface, okay, hard surface, the reflection of a sound wave is called an echo. Now, echo sound can be used to measure depth or to detect object underwater. A sound wave can be transmitted from a surface of water. The sound wave is reflected off the bottom of the ocean. The time it takes from sound wave to return is used to calculate the depth of waters, and the distance water wave is twice the depth of ocean. Now, this is very important. The reflection of sound wave is called as echo. This is a general thing, right? But remember that when it's continuously reflecting, then actually that type of reflection is called as echo. So I want you to write another definition of echo. Okay. What is echo? Let's see. Everybody just write it down. What echo mean is, okay, first of all, okay, this one is sorted. Just leave some space and jump to ultrasonic wave. Now, what are ultrasonic sound waves? Now remember that there is a thing called, okay, guys, the space, please write it down. The repetition of sound caused by the repetition of a sound caused by reflection of the sound waves.
Sir, can you repeat your words lagging?
Okay. The repetition of a sound caused by the repetition of the sound caused by the reflection of sound waves. Reflection of the sound waves. Reflection of the sound waves. Then write another definition for that. Or just put or and write another one. An echo is a sound caused by the, an echo is a sound caused by the reflection of sound waves, reflection of sound waves from a surface, back to the listener. It is the reflection of sound. It is the reflection of sound arriving at the listener, sometime after the direct sound. After the direct sound. So these are all the definitions. A repetition or a partial repetition of sound due to reflection and all these. Okay. Now let's see ultrasound. First of all, remember that if you see that they give you a range of the frequencies in here. Some frequencies are low frequencies, or you can say frequencies, less frequencies. Some frequencies are high frequency, and there is a range they mentioned in the in between actually. Now remember that the range which is in between 20 to 20,000 hertz, that is the range which is audible to a human being. So human being is actually can listen to the wave or sound which is within 20 to 20,000 hertz. Other than that, we are unable to actually listen to the waves. So basically, the range of human is 20 to 20,000 hertz. Remember that this is called audible range. We can hear up to this range. If any sound is more than that or less than that, frequency wise, we will not be hearing, or we cannot hear that sound. So ultrasound waves are the sounds which have range more than that. So this is called ultrasound, the bigger one. And this is called infrasound, which is less than that. Now, what purpose these ultrasound waves are used to? This is used to detect different type of things from human body because they are the sound. So ultrasound is a name given to a sound wave with a frequency greater than 20,000. Just write this quick definition and let me know that you have written that. Put a heading ultrasound and write this definition. Ultrasound is a name given to a sound wave with a frequency greater than 20,000. Okay. Then we have uses of ultrasound. This is interesting. When ultrasound reaches a boundary between two media, some of the waves are partially reflected and remainder of the waves continue through the material and are transmitted. So ultrasound transducers are able to emit ultrasound and receive ultrasound. So basically, it's very simple. When ultrasound reaches to two boundaries, let's suppose there is a window somewhere. Just take it as an example. Some of the waves are passing through, but some waves reflect back. Okay. So it got an emitter as well as receiver. The time taken from reflection to reach a detector can be used to determine how far away a boundary is, and this is because ultrasound travels at different speed through different mediums. So basically, this particular formula can be used to find out the distance, how far the ultrasound emitter and transmitters are. Okay. So this ultrasound wave can be used to find out the distances as well. In a few minutes, we will see to it, but I want you to write this quickly under the heading of uses of ultrasound. Everyone, please. For the purpose of medical and industrial imaging as well. Now, what exactly it is? In medicine, ultrasound can be used to construct an image of fetus in the womb. So actually, this is giving you a picture of unborn baby. That's what it's written here. So ultrasound can be used for to generate 2D image of an organ or other internal structure as long as they are not surrounded by the bones. So, for example, tumors and all these things, ultrasound waves can be used for as a medical treatment, such as removing kidney stones. Again, ultrasound is used for. An ultrasound detector is made up of transducer that produces and detect a beam of ultrasound waves into body. Okay. The ultrasound waves are reflected back to the transducer by boundary between tissues in the path of beam. For example, the boundary between fluid and soft tissue of uh, the bone, which when these echo hits the transducer, they generate electric signals and that's sent to the ultrasound scanner. They're just giving you an idea that how the work being done. When they say use transducer, these are called sensors. Don't be confused with the word transducer. It means sensor. Ultrasound detector is made up of transducer. They are called sensors that produces and detect a beam of ultra wave into the body. So actually what detectors will do, actually these detectors are touched with the body. So our body will start receiving those ultrasounds. The ultra waves or ultrasound waves are reflected back to the transducer by the boundary. So some of the waves are reflected by the sensor between the tissues in the path of the beam. So when these echo hits the transducer or sensor, they generate electric signals that are sent to the ultrasound scanner. And using the speed of sound, the time of echo is return. The detector calculates the distance from the transducer to the tissue body by taking a series of ultrasound measurements sweeping across an area. Time measurement may be used to build an image. So basically, that's how they build the image. The easy way to remember that one is the sensor just sent, you can say the ultrasound is being sent, and the sensor which are near to the body, they receive those waves and they reflect. Okay. When they reflect back on the other side, the sensor is again waiting. So these things are continuously coming and going, coming and going, coming and going, happening. During this reflection and going back into the sensor thing, the tissues of the body and different kind of elements of the human body are in between. So while these continuously reflecting back of the sound, I mean, ultrasound waves are coming and going are happening. So in that way, image formation of that particular organ is being done. Okay. I want you to write that, please. This is all the use of ultrasound. Once you write it, please let me know. Once everyone will be writing this and let me know, please. Once everyone copy that. After that, we will be starting a new chapter, nuclear physics today. The small basics we will be starting from today, and hopefully we will soon be finishing that chapter. After that, we will do magnetism and electromagnetism, and in that way, we will be actually finishing of our 60% of the whole syllabus. And then we will be, inshallah, doing the past paper practice, and then we went to the classic physics. Hopefully, before Eid, we will be on magnetism and electromagnetism. Okay. Once you copy, let me know, please. You just need to know what are the purposes of ultrasound in the medical or industrial purposes. You may not need to write each and everything when if the question comes related to ultrasound, but you should know what are the uses of ultrasound in the medicines. Okay. Yes. Everyone have written this?
Yes.
And what about others? Armina and Ibrahim?
Yes.
Armina, you left. Okay. Let's move if there is anything more left behind. Okay, there is an industrial purpose for this as well. So it is used to check for the crack inside the metal objects, generate images beneath the surfaces. A cracks in the metal block will cause some waves to reflect earlier than the rest, and so will shown up on the pulses on an oscilloscope traces. Each pulse represent each time the wave crosses the boundary. Okay, so just put, I mean, write this down as well. Yeah, that is the last point. I want you to write it down, please. Ultrasound in industries. Same thing is happening when it takes X-rays. Actually, I mean, when X-rays are being taken, same thing happen with them as well. They are just passing through. Some of the waves are reflecting back, and some are passing. So when they are passing and reflecting, passing and reflecting, in that way, they try to create some of the images. Yamna and Armina, did you copy that, beta?
Yes.
What about you, Armina? Ibrahim? And Ibrahim, you?
Yes.
Okay, now let's move on. There is a working example which is being done for you. Now I can show you one thing in this. If you see the question here, on oscilloscope, these are the readings which are given. They say calculate the distance in centimeter from the head of the bolt to the internal crack. Okay, so basically, that is actually given as 0.05. Now, if you see the answer, I mean, the solution here, what did they do? They just multiply time with the 5. So that is your distance S. Now they say calculate the distance. What is the formula we have it? Distance divided by time is equal to speed. Now, what is the speed which is given here is 6,000. So 6,000 multiplied by the time. Time is given as 0.00001. So your distance will be how much? 0.06 meters. When you convert it into centimeters, it will be 6 centimeters. So this is the crack basically internally we have it. All right. Copy this example. Students, did you copy everything?
Yes.
Okay. Now, if everyone copies this, I'm going to start a new chapter as well. That is called nuclear physics from today. And today we will be just having a very basic idea what exactly is nuclear physics and everything. First of all, very basic idea for today is that every single element which is present on this world is actually the smallest entity of an element is called as atom. Now, issue is when the study started, we always thinking what kind of a structure of atom we have it, okay? So there are different kind of structures, different scientists in their times actually came in with some ideas that that type of structures we have it and whatever. So different scientists came with different ideas. First of all, atoms are the building block of all matter and they are incredibly small with a radius of only 1 into 10 to the power minus 10 meters. This means that about 1/10 million atoms could fit side by side across your thumbnail. So this much small you're talking about. Atoms have tiny, dense nucleus at the center with the electrons orbiting around the nucleus. Now, this is the first of its kind, a structure which is actually given by the scientists. Now, what scientists? A proper structure. Before that, there were several structures were given. What was a structure? That this is an atom, let's suppose. Inside the atom, you got a nucleus right there in the center. Okay. This is called nucleus, which is very, very small. And around the nucleus, you will have electrons which are actually revolving in their shells. Now, what exactly in the nucleus? We have neutrons and protons in the nucleus. So, what we say that in an atom, there is a small nucleus in which neutrons and protons are resided and electrons are revolving around that nucleus, right? Now, when you're talking about this, then one more thing came into being is these proton got a positive charge and electrons got a negative charge and neutrons are neutral. They do not have any charge. So why electrons are revolving around the nucleus? Very simple, due to positive charge of proton, because that's what we believe is that positive, negative are attracted towards each other. So because positive charges are attracting to the electrons, that's the reason electrons are start moving in the circle or in an orbit, so that things gonna be easier for us to understand. Okay, so why they are moving in a circle? Because they are moving in a circle due to inter forces between positive charges or proton and electrons, you can say. Remember that. Remember one more thing, that proton are heavier than the electrons. That is the reason why protons are attracting to electrons, not electrons are properly attracted to protons. Okay. So this is the small thing. This is the model which actually came into being, and that's the model we are working on. So I want you to write this, please, quickly. That is a sort of a structure which is actually he proposed. Positive charge means nucleus at the very center, and electrons are revolving around the nucleus in their shells, in their orbit, or in their paths. Okay, these oval shapes are shown as the paths in which electrons are revolving. Students, I'm giving these recordings to our coordinator. If anyone wants the recording, he or she can have that recording from coordinator. Okay. So I'm finishing my class here. In the next class, we will be continuing our class from the same point, and inshallah, we will be continuing with this chapter now. See you in the next class then. Okay. Bye, everyone. Allah Hafiz.
Allah Hafiz.
Okay, take care. Ibrahim, you too.
Allah Hafiz.
Okay.